Okay, so this is part 2 of Quadratic Functions, section 5.1, and we're picking up with the next slide. So we're going to see how, given a graph of a quadratic function, how we can write the equation of the function in general form. So the first thing that we're going to do is we're going to identify the horizontal shift of the parabola, the h, and the vertical shift of the parabola, which is k. And if you will remember, hk, that's your vertex. So that actually makes it really easy to identify the horizontal and the vertical shifts. Now once we do that, then we're going to substitute the values of the horizontal and the vertical shifts into h and k into the equation here, into f of x equals a times x minus h squared plus k. Then once we do that, we're going to choose another point on the graph and we're going to substitute that in for x and for y. So any point on the graph, other than the vertex, because we've already substituted that in for h and k, we're going to substitute that in for x and y, or for x and f of x. I usually choose the y-intercept. So that's a good choice, but it's not the only choice. You can choose any point on the graph. And you are going to solve for the stretch factor of a. Now, if a is opening up, it's going to be positive. If a is opening down, it's going to, if the parabola is opening down, it's going to be negative. And then, this is important, they want us to possibly, well, in this case, we're talking about how to write it in general form. We're going to expand and simplify the equation or the function so that we can write it in general form. Okay, so let's look at an example. So this example says to write the equation of a quadratic function from the graph. Write an equation for the quadratic function g in the figure as a transformation of f of x equals x squared. And then expand the formula and simplify terms to write the equation in general form. So I just want to show you that the graph of f of x equals x squared, the parent function, it looks like this. Okay, so you can see that we've shifted left 2 and down 3. Left 2 and down 3, and that's our vertex, which is negative 2, negative 3. Okay, so substituting that vertical shift into this equation, so y equals a times x minus h squared plus k. So this is our h and this is our k. So now we're going to substitute it into the equation for h and k. So where it says h, I'm going to put in negative 2. And where it says k, I'm going to put in negative 3. So now I'm going to rewrite this as y equals a times x plus 2 squared, because minus a negative becomes a plus, plus negative 3 becomes minus 3. Minus 3. So we're not quite finished yet. Now we need to figure out what our a is. So in order to do that, we need to choose another point on the graph. So I'm just going to pick this one. This is the point 0, negative 1, which happens to be the y-intercept. And again, you can choose any point you want as long as it falls on that curve, on that parabola. You can substitute that in for x and y, or for x and f of x, which this y, you guys, is f of x. So I'm going to substitute for y. I'm going to put it in -1. And I don't know a. And for x, I'm going to substitute in 0 plus 2 squared. Don't forget the squared. Minus 3. So that leaves -1 equals a times 0 plus 2 is 2 squared minus 3. So that's -1 equals a times 4, because 2 squared is 4, minus 3. So now I have -1 equals 4a minus 3. And I want to solve for my a. So I'm going to add 3 to both sides. And I'm going to get -1 plus 3 is 2 equals 4a. And I've run out of space. So I'm going to come up here. And so I have 2 equals 4a. And again, I want to get the a by itself. So what am I going to do? I'm going to divide both sides by 4. Oops. And I get 1/2 equals a. So now I can write my equation. Y equals, or f of x equals a, which is 1/2, parentheses x minus h, and h was -2, so we get x minus -2 becomes x plus 2, squared plus k is -3. And there we go, there's our equation. Now, they want us to put it in general form. This is standard form. So we have to keep going. We have to simplify this out. So to simplify that out, the first thing I'm going to do is I'm going to square my x plus 2. So x plus 2 squared is really x squared plus 4x plus 4, if you know how to do a perfect square. If not, let me show you over here on the side. So on the right, x plus 2 squared is the same as x plus 2 times x plus 2. And if you FOIL that, x times x would be x squared, x times 2 would be 2x, 2 times x would be 2x, and then 2 times 2 would be 4. So I just distributed the x to each of the terms in the second parenthesis, and then the 2 to each of the terms in the second parenthesis. Then we'll add like terms in the middle. You'll get x squared plus 4x plus 4, which is what I have over here. So now we need to distribute the 1/2. So 1/2 times x squared is 1/2 x squared, plus 1/2 times 4x is 2x, plus 1/2 times 4 would be 2 minus 3. And then f of x is equal to 1/2 x squared plus 2x minus 1. And real quick, I just want to tell you something. Let me go backwards to, let's go back to this slide. Okay, so when you have it in general form, C is the y-intercept. So the y-intercept is the point 0C. Okay, and I forgot to tell you that in the other video. So if we look here, A is 1/2, B is 2, C is -1. Look where the y-intercept is. It is, in fact, at -1. So that definitely checks out. Okay, so now we're going to talk about how, when we're given a function, a quadratic function in general form, how to find the vertex of the parabola. So the first thing that we're going to do is we're going to identify A, B, and C. And then we're going to substitute B and A into this equation for finding H. And then once we find H, we're going to substitute that back in to the function to find k. Okay, so they're going to give us, in this equation, in this example, they give us the function f of x equals 3x squared minus 5x minus 1, and they want us to find the vertex. And then they want us to rewrite the quadratic in standard or vertex form. So first we're going to label our a, b, and c. So ax squared plus bx plus c, we can see that a is 3, b is negative 5, c is negative 1. Okay, so first we're going to find the h, which is negative b over 2a. So negative b over 2a, and b is really negative 5, and I didn't mean to do that. And a is really 3. So on top we have 5, on bottom we have 6. So we have 5 over 6. Alright, so then to find k, we find the function at at h, rather. So we're going to find the function at 5 over 6. So that part will be fun. So, because they gave us a fraction. So 3 x squared minus 5x minus 1. And x in both cases is 5 over 6. So we end up with 3 times 5 6 squared, which would be 25 over 36, minus 25 over 6 minus 1. So then we get 3 times 25 over 36 will be 25 over 12 minus 25 over 6 minus 1. You can get a calculator if you need to, but this would be 50 over 12 minus 12 over 12. So let's see, 25 minus 50 would be negative 25. And negative 25 minus 12 is negative 37 twelfths. So k equals negative 37 twelfths. So my vertex is h, which is 5 over 6, comma, negative 37 over 12. So then to write this in HK form, or vertex form, we need A, we need H, and we need K. And those are, let's see, A was 3. H we found was 5 over 6. And K we found was 37 over 12. So we have Y, or f of x rather. So we should write that. F of x is equal to A times x minus h squared plus k. And so we're just going to now go in and fill in these 3 pieces. So f of x is equal to 3 parentheses x minus 5 over 6 squared minus 37 over 12. Okay, so we're going to stop here and we will pick up with part 3.